God, my blood's boiling.
Mike, what's going on, big dog? How you doing?
Dude, I'm excited
on show tonight. Loving it. So I'm just going to jump right into it tonight. Eric's here. He's got some special guests. I'm sure we're going to like hammer down and have a lot of talk today. So I'm not even going to go wasting time. We're going to go right into it.
Jump in.
Oh, by the way, welcome to the Grapevine Show. So here we go. Mr. Eric Kaiser, who did you bring with us tonight?
What's going on, everybody? I mean, if you don't know who these guys are, this is HVAC education royalty right here sitting next to me. I got Mr. Don Gillis, and over there, Ty Brannaman or Bananaman. I'm not sure. It's something like that.
Mm-hmm.
What are you guys doing together, man? Is there like a secret Avengers of HVAC going on that we didn't get invited to? Mike, you feel left out? I feel left out.
I mean,
dude, I'm just gonna be a viewer over here. All right, mute my mic.
Yeah. So look, y'all conquering the world's problems.
If you know how awesome Eric is, and then you get to meet his wife Rachel, who is absolutely awesome at everything, and then you learn that she can cook, and oh my God, can she cook? So we just had like the best meal ever, and then there was dessert, which is just amazing. So we may not leave. We may move in. I think we got a spot over here in the back we can fit into.
Eric's got like 5 acres, don't you, Eric? I mean,
come on, man, throw that guy an extension cord for his camper.
Got an extension cord. I'll hook up to his camper out here.
Yes, indeed. So you guys are kicking it for the ACA conference, huh?
Yeah, so ACA Next Level Conference is in Indianapolis this weekend, and these two fine gentlemen are speaking, or Ty's doing 2 presentations. Don's on a panel
Discussion, yeah, about changing refrigerants. So I'm sharing the stage with I hope I don't butcher this, Hudson and Arkema, which is competitors basically.
Yeah. So if you don't know, Don works for Chemours, and Ty is Mr. Love to HVAC.
Yes.
He just loves HVAC.
He does. Yeah. What's not to love?
Ty's like TikTok famous, Snapchat famous, Facebook famous,
YouTube famous.
You got the Instagram going, right, Ty?
Yeah.
I just try to, if somebody wants to learn, I'm going to try to get the information to them wherever they're at. I mean, that's all it's about, right?
Yeah. Now he's Grapevine famous.
Killing it.
Yeah.
I'm saying.
He's got all the 18-year-old HVAC guys, like plugged in.
He
had that little attention span's like 2 seconds. It's like, bam, here's the video.
Speak when you say something like that, it makes me go right into load calcs, and I think about all the knowledge somebody has to have in their brain to execute a load calc. It is like people say it's easy. I never say it's easy. I say it's a mountain to climb, and it's a fun one to climb, but it takes a long time to get all the way over to where you feel like you're very comfortable about executing one with confidence. So
yeah,
I try to look for those kind of content, because I feel for me, one of the big things that made a lot of things click for me was chasing that piece of knowledge of the trade. Like when I could confidently do a load calculation and understood the nuances between like U value of window, solar heat gain coefficient of a window, different things like that. That's when things start to click and make sense to me, right? About this room could be super big, but it only needs 100 CFM. Oh, what's up with that? You know what I mean?
For me, it was, can you download Windows on an Apple computer? Oh, okay. No, you can't. But Eric can, not me. But yeah, it gets deep, man. I mean, dude, I was banging my head against the wall trying to do like a really good right soft load calc in the beginning, man. Starting from, I know nothing. Yeah.
Yep. I totally agree. It took me a while to get comfortable.
Yeah.
And then you get comfortable and then you think you've conquered it. And then you start to look at grill selections and you're like, oh crap, there's a whole nother level of this I don't even understand yet. And then you have to go down that. Right. And then you get that conquered and you think, crap, I'm doing this with one system. Is this the right move? Am I going to keep people comfortable, or do I really need to split this into two systems or zone it? And you got to think about that, right? And this is all things that the program doesn't necessarily guide you. You have to
Right.
kind of step back and become the expert and say, what's the best strategy for this home? And I say that to follow it up with this. Like when I would give a load calculation to a client, I would have this conversation. I would say, look, this load calculation is my plan for your home, my plan. If you take this and you go to somebody else and they install it, I don't want you to come back to me and come and cry wolf. Like, because this is my plan for my team who understands how I want things done. Right. And I'm willing to stand behind my plan. Right. Because the program may draw it, design it, but then you have an install team. What I mean by that is like there may be some subtle adjustments I build into the design that allows for my team's quirks, right? And how they install.
How we doing on our topic tonight, Ty?
Oh, I think you're right on point.
Okay. good.
Sorry.
Ty was all worried about, he's like, I don't know anything about mold. I'm like, since when do we stay on topic?
Never. We talk about food for 45 minutes.
Right on.
All
right,
right,
so
Italian, you know.
Not to derail your diatribe there, Chris. That was great.
Go ahead. Go ahead. Well, I think it's a leader.
Chris was
our
leading
topic
into
tonight.
a good load calc can keep you away from mold.
But can it?
Well, it could be a shitty, load calc.
It can get you closer, right? I think this whole conversations today is about narrowing the gap, right? No load calc, you have a good chance. Load calc, you have less of a chance of having mold. And then there's other things you could think about to not have mold.
Blower door.
That's where I'm headed.
Duct
Well,
leakage, yeah.
So I think our goal here, really, we're talking about mold tonight because we're kind of in that shoulder season now where mold is starting to occur more, right? Because we don't have the runtime on air conditioners, so they're not doing the dehumidification that they really should be.
That's right.
And it's up to the HVAC system and the equipment that we put in, whether that be the cooling or the dehumidification equipment, how we set up the ductwork, how we put this in. It's up to that equipment and that subsystem of a house to control that, the conditions in the house so that we don't get mold. And we have to know how to spec the equipment. We've got to know how to set up the equipment. We've got to know how to put in the ductwork properly. We've got to know how to distribute the air. And so the goal is really to think about, number one, we don't want mold to grow anywhere, right? So then we have to figure out, to me, the first step of that is figuring out what are the conditions in which mold will grow.
That's a good place to start.
Yeah.
Absolutely.
So
Go ahead.
we've got to learn what kind of conditions that mold will grow in. And then we have to figure out how to not make those conditions or control it away from those conditions. That's my thought process with this.
Yeah. I like it.
Who's going to
So-
go over conditions?
Well, I was going to do that. I was going to have some slides here, but they're on my other computer. And as I sat down here tonight and I looked up at the screen and I went, I'm on the wrong computer and I don't have my slides. So I'm going to talk about this a little bit. Because and the other problem here is that if I had brought slides out, I'm pretty sure Ty would have been out that door over there in 2 seconds. Because if anybody knows Ty at all, Ty can do an entire presentation with one slide, and that's the title of his presentation on the screen behind him.
I like it.
So mold, right, needs moisture first off to grow. That's what it really needs to grow. But it doesn't necessarily need visible moisture. A lot of times when we think about mold, we think about it from water on a surface that we can actually visibly see, and that would be condensation. But what happens with mold and what happens with surfaces is the higher the relative humidity in the room, and this is where there's two things we have to look at here, and that's relative humidity and dew point. All right. So our dew point typically has a lot more to do with human comfort in the space as opposed to whether or not we're growing mold. If you got surfaces that are hitting dew point and condensing, chances are you're going to start growing something, and you're probably going to start doing it long before that actually hits dew point.
And the dew point number is when you start to see visible water droplets. Is that right? Or
Right.
no?
So that the dew point number is where that surface temperature aligns with the 100% relative humidity in the air. So when you
Okay.
drop that air temperature, whatever humidity's in that air, whatever absolute humidity's in that air, flipping over here to the comments, I didn't realize I wasn't on the comments screen. I was like, man, there's nobody watching tonight. And apparently it's House. Michael House and Mike Barnes are watching tonight.
He's lit up.
Oh,
Yeah.
damn.
Literally lit up.
Mike's in the house.
Mike
In the
is
house.
in the house tonight.
House
Mike's
is on it.
We
house
need like
is in the
30,
house.
30 more comments. We're just bringing Mike into the show tonight. You know what I'm
Yeah,
saying?
bro. We got one more square, bro.
He's
Let's
got a
go.
lot to say.
So
He's on the Four Roses tonight. Mikey boy, hits for you.
Mike and Mike on the Four Roses, huh?
He got me going.
So what we got to look at is, right, when that surface there next to the air hits that dew point and starts condensing. That's your dew point of your surface. But what we really have to be looking at is mold starts growing on that surface somewhere around 70 to 80% relative humidity. So we actually have to keep that surface temperature. If we have a condition in a room, we don't really want to monitor that temperature out in the middle of the room. We need to know what that temperature is up against the surface to keep that relative humidity immediately against the surface lower than that 70 to 80 relative humidity. So this surface back here has to be controlled. We need to control that surface temperature, not just the air temperature in the room. So it becomes, how do we do that? So what do you guys think? How would we control this surface out here when all of our sensors are set up to sense the temperature out here in the middle of the room somewhere, not on the exterior wall? Because this is an exterior wall of the building, by the way, right? That's the first thing we have to control. So what do you think?
Let's just run heating elements in the wall, and so that way we keep the wall hot at all times.
Yeah.
And then we don't have to worry about it.
That is brilliant. Why don't we just bury a whole bunch of hydronic lines in our walls?
Perfect.
Wall reheat. I like it.
Wall reheat. This is brilliant. Don, John's like, what did I just get myself
Yeah.
into?
Yeah. I was going to say condition that, but I don't know. I like the running the water lines through there.
You like that? I thought that would be awesome years ago. I always thought, man, I would love to just run like water lines in my wall. That would be so cool. And you can do that. It's called, a lot of people actually do it with the evacuated tube solar collectors. They'll for heating side, not for cooling side,
Mhm.
but they'll run water lines in everything in a house. Stairs, they run them under countertop, they run them in every surface in the house because it's really low temperature water.
There's something someone has to fill a gap for me that I don't understand. Because I'm not from a location where, that's commonly done, like floor heating and things like that. Don't you want some type of air movement? If your whole house is being heated and cooled from conduction, what's circulating the air? Is it mandatory that you're having ceiling fans turned on to kind of get a little air movement? Like what's going on there?
When you
And
have
how does that feel?
when you
Yeah.
have a
Because we saw the boys.
a hot surface, right? When you have a warm surface, what types of heat does that provide to the space?
Does it throw like a little
Um,
radiant? Like if you're
I'm-
heating the floor, we're talking about the floor,
If
right?
a warm surface,
Conduction?
well, I mean, if you're standing next to this and this warm surface, if I'm say 6 inches off of that, and that surface is say 120 degrees, that's a good temperature for a radiant floor or radiant heat, 120, 110 sometimes.
Okay.
That's 110 degrees. Can I feel that when my hand's not touching it?
I'm sorry, I zonked out. Sorry.
I think you could. I think the answer is you could.
So if you got your hand say 6 inches away, you could feel that radiant heat coming off of there.
So
So
just
that-
like in the winter, you could feel a cold window, like a ghost staring at you.
It's
I-
all that heat transfer from hotter to colder, so higher to
Okay.
lower, right?
So I'll counter you with a conversation that I read in Manual T the other day, because the other day I was just reading Manual T to catch up, and I learned something in Manual T that like your legs and your feet generally will stay warmer than like the upper half of your body, because as you air I'm going to paraphrase this because it's not going to come out just right, but anyway, you can move air faster across your legs and your legs are okay. But if you move the same amount of air to your upper body, you're going to feel cold, according to the way it's kind of written in Manual T. So if you're got a radiant floor that's warmer and you're naturally warmer on your legs, wouldn't your legs be hot while you'd be comfortable up top if you're not circulating that warm air from the floor around the rest of the house? I know that got deep, didn't it?
Yeah.
Damn.
Weird.
Well, so I haven't seen
When
that.
we going to talk about mold? That's what I want to know.
Yeah.
We're
We're
on it.
getting there, Michael. We're
Yeah.
getting there.
I haven't seen that type of insulation, but I have worked around a lot of geothermal and boilers and stuff. So the only time I've seen radiant heat, I'm from obviously the same area Eric is. We're in Indianapolis. I'm licensed in Fort Wayne, but is like your bathrooms when they went to the heavy tile and stuff like that. That gets really cold in the wintertime. So that
Right.
became very common 15, 20 years ago in nicer homes. And now it's like in basic homes now. The other places up here, again, because of the weather, is we run a lot of tubes in like nicer high-end homes for the driveways or loading docks at contractors' places to de-ice, those kind of things. They keep it
Oh,
just,
yeah.
they warm that up. And gardeners
So you don't
outside.
have to shovel the snow anymore.
Exactly. Yeah, exactly. It's safe to work on and stuff like that. Those are some of the projects I've worked on. And then also like
$20 a
greenhouse.
driveway. I used to
Yeah.
shovel snows. That's taking business from kids away. I don't like it.
I think there was a lawsuit filed, but
Yeah,
They put them in anyway.
yeah,
the Kid Shoveling Association.
yeah. But greenhouses do that a lot too. If they're on slabs and stuff like that, they'll run the boilers and the tubes and stuff.
Well, I don't know. What do you think, Ty? You think you'd be unhappy, or you think you'd be happy with cold feet or warm feet?
Warm feet.
Warm feet, right? I mean, if you ever had cold feet, clearly you guys live in the balmy South, so you don't understand what it's like to have cold feet.
What is
Yeah.
cold?
When it's cold.
When my feet are cold,
When
I
you go
feel
past the Georgia line, Chris, that's about it.
Yeah, right.
What are those?
Oh,
The Mason Dixon
Are
line?
you
I
talking
don't know.
about the other column when I do a load count? It says like heating. I don't really pay too much attention to that. Is that what you're talking about?
You know, it's funny, bro. You mentioned that. I actually took that off of Cool Calc, my last load count. Does this heat the area? No, just get rid of it.
Yeah,
we just open the window to warm
that's
things
not
up.
important. Yeah.
Oh,
But no, so what other kinds of heat movement are there? I mean, there's multiple kinds of heat movement, right, Ty? What do we got here?
We got conduction. We touch it. We got convection, to where it's also as it heats that air next to it, the air becomes less dense or lighter. So then the heavier air pushes down. It actually lifts that lighter air up. So that's convection, conduction, convection, and radiation. Or we can do the French one, radiation.
Right. So
Yeah.
if you have a room with a heated floor in it, and it has walls that are cooler or taking heat out of the space, right? They're cooler. So warmed air is going to get warmed along that floor. It's going to rise up in the middle of the room, heating the people in the middle of the room, and it's going to fall down. So you're going to create a natural convection current in
I
that
like
room.
it. I like it.
I could see that. Yeah.
It's the
So-
same way the old gravity furnaces. If you guys may have worked on gravity furnaces before, right?
Yeah.
But they were literally just a burner, but they didn't have a blower in them,
Yep.
and it was all
Right.
gravity circulation. They would bring that warm air up in the middle of the house. It would go around the outside of the house and come back down, and all the returns were on the outside walls.
So in Florida or Louisiana, we could just do cool ceilings. We'll invent a new product. Call it cool ceilings.
Yeah.
Well,
I love it.
that becomes a challenge, though, right? Because
We got moldy ceilings.
you could have
Mike, I think we're gonna have to run tubes
Really
in our
fast.
ceilings.
Yeah.
Right. And then we're just gonna run, 30.
It'll be like a new
36
sheetrock,
degree
bro.
water.
All right, sheetrock in the ceiling, and that's it. Run tubes in there.
When I worked
Yep.
in Miami, one of the penthouses
Don't
down
have
there
any
on South
kids.
Beach, the guy had these huge Spanish tile floors, and he had hydronic heating in it. in
Nice.
Miami. So he had air conditioning, so he was actually cooling the air and dehumidifying. And then he also had the floors heated because he wanted to, when he walked on a barefoot floor, to not feel the cold of it. But also it worked great for dehumidification. So he was reheating the floor.
Yeah.
Oh, it a
you know,
reheat.
at load.
Yeah.
So, but it was
Yeah.
nice. You walked in the tile and it was like, oh, that is great.
Did he have a tiger in the backyard? Was his first name Tony? last name Montana?
We didn't know.
Reheating the floor, bro. I love that. It's got to be expensive though.
Yeah, that's pretty cool.
That's
if you-
lifestyles of the rich and famous right there.
If you can afford Ty Brannaman to come in and work on your HVAC system, I'm pretty
enough
sure you
said.
can afford
Enough
Brady
said.
heating the floor.
Yeah.
So
Ty got flew into Dubai last week for a consultation for the
That was
prince.
Saudi Arabia, and that was 3 years ago. So not
So-
recently.
See, I ain't making this shit up.
I'll steer this thing back to mold for a second. And I want to take this down the road to inverters and have a conversation. Because, you know, the industry has this whole mentality, and I'm not going to say the whole industry. There's a lot of people who, I think builders get this impression. I've been to builder shows and you hear builders say, well, who cares what tonnage it is? Isn't it going to turn itself down? Is the turn down ratio going to handle it? That's not what they call it. They have their own terminology for what they think it does. And I'm like, no, that's not how that works.
It'll
You know
step
what I
down
mean?
to a 1 ton, right? If I throw a 5 ton in, it'll work fine, right?
Yeah. So it's something I think that we should discuss when we're talking about mold and shoulder season and why you should aggressively size your air conditioner when you can. I'm working on a project right now for TEC, and, you know, looking at load calculations and equipment. I'll just go ahead and say, like, we're putting in a Mitsubishi system, and there's a 2 ton and a 2.5 ton. And the capacity rating on the 2 ton is 24,000 BTUs. The 2.5 ton has a maximum capacity rating of 27,000 BTUs. Now, here's a tough decision that I'm having to make. Hear me out.
Yeah.
If I go with the 2.5 ton, the hyperheat, I can get a lot more heating capacity, and I could almost eliminate the need of ever needing to run electric heat.
Right.
But if I go with the 2 ton, my turn down ratio, because it'll even list it on the spec sheet. I'm looking at it right now. The minimum capacity on the 2 ton is 8,800. That's a low run capacity, right? And so this thing could throttle back.
Hold on. What's your minimum capacity on the 2.5 ton then?
Oh, I don't have it pulled up, but I remember looking at it. I want to say it was 13,000 BTUs. So
That's
I've got
a big
I've got a
difference,
5,000 BTU spread on the minimum capacity, which means, you know, like when I want it to throttle down and run
Right.
longer, I'm going to have better chance to do that with the 2 ton over the 2.5 ton.
So when you look at that though, what is your, because you're talking about heating capacity on one side.
Yep.
What's your cooling capacity on the for the house?
Well, that was strictly talking cooling capacity right there. That was all cooling capacity talk.
Okay. All right.
Sorry, I didn't make that clear.
What's your cooling needs for the house? I don't know where this
So
thing keeps-
I have been playing. I have ran multiple loads, to be honest with you, and multiple adjustments, and it's basically it was 22,000 or 23,000. Then I had made the decision to add ERV. Then I had to calculate what the ERV would do, and that brought me down to like 20,000 BTUs, which allowed me to definitely go with the 2 ton. Because I was looking at some point during the load without the ERV, I think I was actually above 24,000 BTUs. But with the ERV and the exchange on it, that was going to bring me down right below the 2,000 mark, or the 2 ton mark, which made the 2
in fresh
ton
air
more
brought it
sense.
down.
Bringing fresh air into an ERV with the exchange of enthalpy on the ERV allowed it, you know, to me to reduce the load. I think it came out to like a 46% efficiency rate on that ERV.
So when that throttles down to the 2 ton, what does that do to your sensible heat ratio? Does it stay constant, or do you lose some of that latent capacity?
That's a good question. I don't specifically know, and this is something that kind of aggravates me. In the literature, they publish a sensible heat ratio, sensible heat factor of the coil. And I noticed on the 2.5 ton, it was like 0.83, and on the 2 ton, it was like 0.78. But that's probably going to fluctuate, of course, with airflow. Like I can manipulate that sensible heat factor.
I got another question for you. So you're calculating the efficiency of that ERV at design temperature, right?
Yeah.
I'm trying to remember. Yes, it would
Okay.
have been. Well, I think I might have done it 2 ways because I found an ASHRAE website that would show me 1% dew point of the out of the year, and I could calculate it that way. Then I could do it off load calculation design. And I could do it that way.
So what is that? What happens to that efficiency, say at 72-degree outdoor temperature?
Man, you having me dig deep. I don't have that in front of me.
Dude, that
Because that gets
That's
into
nice.
exactly what we're talking about right here.
Yeah.
That's
Because when you don't have a temperature differential between those airstreams, your inlet and outlet airstreams on an ERV,
Right.
what happens? There's no temperature differential. So how are you going to transfer heat? At that point, all it is an air circulator. Is it going to transfer any humidity with that too?
I think it would depend on where you would pull the air into the ERV from, right? So there's some choices with an ERV, and I'll be the first one to tell you this project has been an eye opener for me because I don't deal in ERVs. This has been a learning curve that I'm enjoying greatly because I'm learning a lot that I don't know about ERVs. I've seen them commercially. I didn't design them. I've worked on them. And we're talking about the big boys. I'm talking about huge enthalpy wheel turning. And I'm just out there for like maintenance, repair, and all that good stuff. But like to design an ERV into a project, this has been an eye opener.
same for me, man. Like that's like digging
Yeah.
really deep. Like what
Yeah.
Eric's saying, like, oh, at 72, like, oh yeah, no.
No, I totally hear what you're saying. But I think one thing that's interesting is if I was going to do it and I had an unlimited budget, I'd probably be pulling my bathroom exhaust through it. Something I've been thinking about. Like if I put one in,
Friend of
because I
mine
don't,
did that. Yeah.
bathroom exhausts are noisy and annoying,
Yeah.
not
Constantly get
filtered.
the
So the
smell out of
fan's going to
there.
get nasty, and if I could pull that air from the bathroom, especially because the bathroom's going to be, there could be a moisture load going on, bring that to the ERV. I don't know. I think that's an interesting take on how to throw a little twist to an ERV. I don't know how many people do that.
So what's that going to do? Let's think what's that going to do in your ERV if you have humid air coming out of a bathroom and humid air potentially coming in from outside, crossing each other.
Right.
Well,
What's
or
that?
you have dry air coming in
Yeah.
from outside.
What, in Louisiana?
No,
What's going on?
Las Vegas.
What part of the bayou we talking about? The voodoo side?
well, this
That's dry?
project isn't by me. It's further up north.
We got to start off with that. I'm just thinking,
Yeah.
Well, but again, this is part of where we have to consider that for mold is what does that do all year long? And this is where I think
right.
that we as an industry are really missing, and you guys weigh in on this too, Ty and Don. I think that we as an industry are thinking about load calculations in a very 20-year-old mentality where we have single stage equipment and it's either on or it's off.
Yeah,
right?
dude.
And now we have so much more technology. Like we can do part load things. We can make changes at part load. We're starting to figure out that, hey, we've got to consider what's going on in these shoulder seasons in humid climates. And we're talking to the people in humid climates here. Y'all people live out in deserts like Ty. You don't have to worry about that because there's no humidity to worry about. They don't care. He just has, animals stop by his
Yeah.
house sometimes.
His 500 CFM per ton over there. Yeah. All right.
But I think that we as an industry may be missing some pieces.
Yeah, dude, you're onto it, man. What about the rest of the
What-
friggin' year?
Yeah.
What about the rest of the friggin' year?
We're sizing for that 1%, but now
Yeah.
we have equipment that can run, say, 80% of the year. Why are
Yeah,
we
man.
not looking at the rest of that 80% when that's where we spend the most of our time.
What about the nighttime? Right?
Yeah.
It's
well,
dude, it's like 85 degrees out. The dew point was like 75 yesterday. It's killer over here.
I'm gonna let
You know?
Don and Ty take that one.
Yeah.
What was the question?
So do you think we are thinking as an industry, do you think we're thinking about this in a very single stage manner? Do you think we should maybe be changing the way we think about that as an industry and looking at how this equipment performs at, say 50% capacity when it's an inverter, or, how it performs at minimum capacity when it's an inverter, rather than our standard method of doing this with manual J and manual S is we're looking at that 1% sizing right now.
So we should always be looking for more as an industry. We should always looking at growing. But I think one of the things that we miss out on is we look at tonnage and we say, oh, we need a 2-ton system. And so even on standard tonnage, we get people, oh, well, I'll just put in this brand or I'll put in that brand because it's a 2-ton. And we don't realize that all 2-tons are not the same. We have to look at that sensible capacity of that system. Because I've seen somebody take a 2-ton out, put another 2-ton in, and it had a higher sensible capacity and a lower latent capacity. Then
Right.
the homeowner has humidity issues, or they have leaking ductwork, and now they're pushing air out of the house and they're pulling moisture back in. So we have to look even on standard single speed equipment, thinking of the whole house. Hey, where's the air coming in from? Where's it going out from? And the capacity of that system. Everyone's like, oh, just add more airflow. Just add more airflow. Or, oh, it's humid. Just drop the airflow down. And it's not quite that simple. So even on standard equipment, we have to look bigger. And that's what we should be exciting for. It can be overwhelming, but we should look at, hey, I'm not solving the issue. There's solutions out there. And that's where you get into these rabbit holes, which can be overwhelming, but it's fun. We talk about these ERVs and people get overwhelmed quickly, but it's fun. You start thinking about that, but start somewhere and think, hey, when somebody says that they're comfortable or what comfortable are they at, start looking at humidity and seeing what the humidity is. Start looking at dew point, start looking at these numbers to have something to compare to. But then we get into variable speed and it sounds great. Hey, this equipment will speed up and slow down. They keep you exactly what you need to be. It sounds good. I would love it if I didn't have to stop at red lights. I could just speed up or slow down. But in reality, we have to think of not all the variable speed equipment is the same. Some of this variable speed equipment, yeah, it's slowing the capacity down and your sensible heat number is good. Your SEER rating is good. But you look at some of the equipment, when it slows down, you lose dehumidification. The temperature of that coil goes up.
Yep. And that's exactly what we're talking about.
Humidifying. And then you're just recirculating air and it's the air is humid. It's still humid. It doesn't actually pull the humidity out, which is our huge need. I don't think we should have thermostats that say temperature. I think all thermostats should have temperature and humidity, or ideally dew point, but that's a big push. But we can't just look at temperature. I hate it when they say, oh, what's the perfect temperature to keep your house at? And they ask a company that has a lot of sales, or they never look at the humidity. Oh, here's the temperature. We did this study and this is the best temperature to sleep at, but they never talk about humidity. So I'm like, I take the studies and throw them out the window. If we're not going to talk about humidity, we cannot talk about comfort. We cannot talk about the health of the building itself or the occupants.
I totally agree. So
Love it.
I told you earlier, I worked with the weatherization program at Fort Wayne about 15 years ago. So they taught me so much because we had to take the same classes. So I had to learn about all the stuff they do. And they came in, I told you earlier, from my basement. But what I did was once I started to understand what they were doing, the whole envelope and stuff, I bought one of those. Now they're real popular, but at the time they were kind of cutting edge. It's whole house dehumidifiers with the 10-inch collars on them. I won't name the brand, but tied in the ductwork. And what used to be comfortable at, let's say, 70 degrees in my house, and the house is 120 years old, so it's an old house. But then it became like 76, and people, it literally feels like you can. So I started understanding more about that earlier in my career about that stuff, but not in the depth you guys get into it at all. But humidity, I think you're right, and that's what my Sensi, and I shouldn't name drop things. It has the humidity on there and all those things, and I like to really watch the humidity. And I hear you talk about it a lot too. So I still have a lot to learn in that area. But yeah, I'm a big believer what you said. Really, more control of what the humidity is and that kind of stuff. But yeah.
I love how humble he is. He says, "I got a lot to learn." Okay, yeah, right, sure.
Well, you guys get into, I mean, we used to do the whole thing, the blower doors and the Pascals and the ventilation pulling out, turn all fans on. You know how they do it, to turn the bathroom fans on, all that stuff, and make sure, your draft doesn't pull from your water heater and stuff like that. But you guys are way beyond what, we were just scratching the surface. You've been to the same place I've been. Here in Indianapolis, it's got a really big facility called Inca in Indiana
Community Action
Network
Network or something like that. Yeah.
At one time, like Bill Spahn, you said, man, that's one of the biggest facilities in the nation. And that's where we were trained at in Indianapolis. We'd go down there to be certified for BIP certification. But when I listen to you guys, what you do here and everybody that's in that world, Mike Hosh and Hausch and different ones like that, Nate and what have you, it's way deeper than we ever got into or that I understood anyway. So there is a lot to learn from me, but it's not the world I live in all the time. Like you guys are in that world. I see Chris smiling there. Look at him.
We get in the weeds and we forget
No, but it's
how
cool.
much.
That's why I'm that's why I'm just listening, because it's cool to absorb all that.
You got to remember though, like a couple of years ago, I jumped in with TEC and I'm saturated in it. Right. So the idea of not doing it now is like, I couldn't even imagine. Right. But let's go back years. I didn't know what the hell I was doing. I didn't understand half of this, Pascals and blower doors. I mean, there was a time in that market, I was super green and super ignorant. I would like to say I'm proud of myself because like in my market, I was one of the early adopters who brought a lot of that to market in my area. And I hustled, man. I went and got BPI trained, bought the gear, and then I called all my buddies and I said, hey, I got you. Like, you're going to have to pay me, but I got you, and I learned a lot doing that. But
I find it amazing that we still have our bathroom fans, the exhaust fans, on a switch. So the bathroom is full of humidity, and then you just walk out, you shut the switch off because nobody wants to waste electricity, and we just leave all that humidity there just to work its way to the rest of the house. Just
agreed.
Isn't it crazy?
And that's
we should.
That's a great point. When just what little I knew about even the years ago in the weatherization program, they had these really nice. They were state jobs, so we were forced to put these Panasonic. You're familiar with them, I'm sure. You guys are all familiar with them now. But years ago, that was kind of like cutting edge. But they were all based on humidity, and I thought that, man, that's cooler than heck. It would go off on. I'm talking about, Eric.
Yeah.
We go off on humidity and had nothing to do with turning on and off. And I thought that was cool as heck, that technology.
I mean, we can, we can even put humidity sensors in place of the light switch today. I mean, they've got a humidity sensor that goes right there in the wall. So if you don't want to replace the whole fan, now you can just change the switch on the wall too.
Yeah. They got that at Home Depot, I think. Yeah.
Huh.
Yeah.
Yeah. It's really nice. Cause I mean, you nailed it, dude. Some people take a shower where they're melting the skin off their body, hot. 150 degrees, and then you got some people normal showers, but that humidity just sticks on the walls. It's like you said, Ty. I mean, just I don't know. You're gonna turn it off, turn it on. Like we should have smart sensors in the house.
And I mean, we don't at the same time we don't want to let that fan run too long because a lot of times those fans will put a negative pressure on the house.
Yeah,
and, you're dropping that house pressure a couple of pascals maybe, but that's enough to bring in a significant amount of humidity into the rest of the house. While we're trying to take humidity out of the house in one spot, we're bringing it in somewhere else if we're in a humid climate.
That's why I love that podcast that Bill Spone had with the Serve too, man. I was so excited. But I was just a little sticker shocked on it, but that is the jam, man. That's a ventilation heat pump. It's got sensors. It's amazing, man. That Serve 2 is amazing.
Oh, go ahead, Ty.
I had a consulting client. They had a system that was just a customer was unhappy with it. And they said, look, our temperature's good. They're unhappy with it. So I came out there, checked everything. Humidity was through the roof high. So we did some tests. We found out that the sensible capacity of the system was great. The latent capacity was great. It was pulling humidity out as fast as it could. The system was sized correctly with the house. So, okay, well, your problem's not with the unit. The ductwork was actually sealed. The unit wasn't in the attic, which was awesome. I love seeing that. Wow. And so we're checking around. It's like, well, we have high humidity. The unit's pulling the humidity out, but your question should be, where is it coming from? Moisture's coming in. And then they started having allergy issues, which was related to the M word, which I don't like to say because I'm not a mold certified expert. So it was some kind of a growth. But as we start looking through the house and start looking for it, it's like, well, we got moisture coming from somewhere. And just start using your instruments and checking around. We found out that it was coming from the slab, the concrete. And what turns out, they had a busted pipe. So we shut all the water off, watched the meter, and you could see the meter going. And so we found out they had a busted pipe under the house, and that was causing their humidity issues and their growth issues inside the house. And the customers blaming the HVAC guy. And the problem was, when you look at that bigger picture, it wasn't the HVAC system at all. So the contractor was like, "Hey, I'll write you a check. You saved me thousands. It's awesome." And the
That's
customer's
awesome.
happy too, because they could go after their real problem.
Freaking slab leak, dude. That's crazy. I see it all the time down here, man.
Yeah, on older houses up
And
to
They're always cracked.
yeah, the storm drains will crack, and then all of a sudden water will run back to the plenum underneath the slab.
Yeah, you got to say no to crack.
Crack kills.
I did.
Apparently,
And a lot of these slabs, dude, they make them quick here in Florida, and there is slab cracks everywhere. Like you'll get, I mean, dude, I got termites in a brand new house going with steel studs with a concrete block, CBS block with stucco, right? And they were like, we'll go after the molding. Great.
I was about to say,
it's-
what's a termite going to eat in that house?
That's what I'm saying. Like, what the heck, bro? I'm like 80% concrete and metal. You know, it's like it's nuts. And I found out that when I ripped up the carpet, I mean, what the slab, people don't know that slab is really porous. Just put a gallon of water on that concrete. Just like what Ty was saying. If you have a slab leak, and God forbid it's hot water side leak, it's gonna just steam up through the carpet and just into the environment. Like I tell my friends, are you going to do new carpet? Paint the floor. You know,
See, if you have concrete will conduct water for miles.
yeah,
If you get a concrete, like if you had a cylinder of a concrete inside of a PVC pipe, I forget how many, it's hundreds of miles it will conduct water
really.
through it.
It's like
Yeah.
a sponge. So I told him just paint it. He's painted it. 45% relative humidity in this guy's house. Middle
Yeah,
of
if you
summer.
paint the top of it to seal that water down in the concrete, not let it come out,
Yep,
will help a bunch. Just
It
some
was
good water seal paint.
dry as heck.
hard to
Yeah,
learn.
Yeah.
yep.
Yeah, I mean,
Yeah,
I
we prevented that M word. You know,
I prefer to have that vapor barrier under the concrete before the concrete is ever poured.
Mhm.
But
Yeah.
you know, if you can't do that, seal it in the top too. At least you're going to
Yeah.
help some.
you know, it reminds me, in a lot of load calc software, they say like slab insulation. We don't have no slab insulation over here.
Yeah.
Yeah, we
So
don't
make
either.
sure you guys are going through like when you're doing a load calc, make sure insulation value for slabs is correct, you know.
So let's talk about something else, because some of the other problem places we get where things start growing is especially on like around registers.
Yeah.
And inside units or inside ducts. I mean, I think we've all seen those pictures when that starts happening, right?
Always in a 4-piece.
Sounds like what Eric's going into is action items, and y'all know that I like action items.
This guy and his action items.
Turn it up.
Chris and his
Yeah.
action item,
Oh,
man. He's all
I'm sorry, Eric. I said 4-piece. I meant to say 5-piece.
yeah, it's a 5-piece. It's got a top on it, because if it's a 4-piece, it ain't got no top on it, Chris.
That's right.
Well, can't you just put in this magical device that just magically kills all the mold, makes the air clean?
We're not talking about those here.
Okay.
We're not talking about the Remy Halo tonight. Come on, bro.
Oh Lord,
It all depends. It all depends. And I digress.
We just gotta ignore chemistry. It's no big deal.
It's got hydroxy radicals. Come on.
I think it cures cancer too. And they used it at NASA, so it's gotta be true.
The
Anyway,
hydroxy radicals even make your teeth white. Come on. It's a win-win for everybody.
so when we're talking about things growing around, say, ceiling registers is a really common spot for stuff to start growing, right?
Yeah.
are we talking the outside of the register or the register itself on the fence?
Either
There's
play.
a difference, right?
I mean, what about the ceiling around that register?
Yeah, that's what I'm talking about. Are we talking what's causing around the rim or causing it on the register? We should because people are watching and they're probably maybe haven't heard this spill before. They're maybe thinking, well, what do I need to do? What's my action item if it's on the sheetrock around the register, or what's my action item if it's on the register? Right.
Well,
Where are we going from here? What do you think, Chris? What do you guys,
Okay.
what do you guys think? What
let's
should
go
we
for the dirty ring around the grill. Let's start.
I'll tell you what. I'm gonna let Ty and them go
Okay.
But I have an interesting add to this conversation from an investigation me and my friend Leaf did on a house.
All right. So,
What do you
the two options are that sweaty BO ring around the grill, and then the other one is like the fins and just right, and in the boot maybe, or would that be option 3?
That'd probably be option 3.
Okay, we got 3 options, and go.
What do you think, Don?
What was the question about whether? Okay, so we're talking about
We're-
mold
we're-
around the edge.
Yeah, we're trying to
or on
figure
the
out
fence?
how do we stop that mold from growing? That ring of mold goes around the register, or as Ty likes to say, the M word.
Yeah,
You
the
know,
M
on,
word.
on the ceiling.
around the register. So
Yeah.
you've got these heat runs are in the ceiling.
Yeah,
So you'd have to have some kind of vapor barrier around the ductwork of the boot somewhere, or get that sealed up.
well, this happens on the bottom of the ceiling, like
Okay.
in the room, right, where you
Okay.
get kind of those black streaks and stuff coming out. You probably I don't know. You being that far north, you might not get a lot of that.
Yeah,
I
just
don't,
pretend you're in Florida
Yeah,
and you're at a convention,
Yeah.
and you just look up.
I'm not familiar. Oh, I've seen those.
Everything sweats in Florida.
Go off. Thank you. I do know what you're talking about. So yeah, I'm not really that familiar with that, but
Yeah.
What do you think, Ty?
Well, you got several things to look at. You got what is your humidity in the space, because as that vents, the air's coming out of that vent, you're recirculating air in the room around it. So you can have, once that's below dew point, you're having moisture collect and mold. You can have it where the grill itself mounts. If that's leaking air through there, then you're blowing that low temperature below dew point across that ceiling. And then you have the temperature of the air inside the duct, which I've seen that be at dew point temperature, and actually the water collect in the duct itself, and then where it actually literally runs out into the grill. And then because the grill is a metal surface, if the temperature of that air is blowing on that grill, that's going to be below dew point temperature, the moisture in the room will collect on that grill as well.
Yeah.
Did it hit all 3 of those? Your satisfaction?
He
I've
nailed
got a-
all 3. Shit.
I've got a fun ad here.
I knew it.
So,
I was hoping for this.
so what do we do to solve that problem?
Let's reduce the humidity issue and control our airflow property to match our load.
Yeah, nailed
Okay,
it.
but so if let's just say if we have to get our we got to have a cold coil to get our humidity out, right? So we're going to run our coil down around like 42 degrees, which is going to make our air coming out of that register probably 52, 55 degrees, something like that, somewhere around there. How is that in relation to our dew point and our relative humidity next to that surface?
But this is where I love what Michael Hausch is doing with his Frankenstein system and having an air bypass.
Yeah.
And what you were talking about earlier, to where we can actually have the dehumidification we need, have the cooling capacity control we need, and then we can increase the air temperature by diluting it with the return air, so our duct temperature isn't below that dew point temperature. And I think that's a huge thing that we don't look at enough. And I've been following Mike on it. He's doing what I've been dreaming
Dude,
about.
it is cool.
But it's so important because when I'm in Florida, I see people say, "Oh, we don't like metal ductwork because it sweats." I'm like, it doesn't matter if it's metal ductwork, it's ductboard, it's still sweating. You just can't see it on the ductboard, but it's still happening. It's still there.
Still sweating.
When the temperature's below dew point, it's still happening.
Yep.
Yeah.
It's still
Especially when you
sweating.
got silver ductwork in the attic and it's all buried in insulation, right?
Yeah.
It never-
Go up there at nighttime. See what
Mike?
happens at nighttime.
Mike, does that ever
All right.
sweat?
Dude, I'm going through sweaty ducks right now with one customer.
You got
I got to
sweaty
throw
duct
something
syndrome?
out there. I mean, we're getting super technical, and I enjoy it. But I'm gonna take this back to what like Gary Nelson has told me. He said it's all about putting caulk in the cracks. He
Caulk
said
in the
that's what it's all
cracks.
about. He's like, we could overthink it to death, but it's all about getting caulk and cracks. And what we haven't really talked about is taking the register down and making sure the boot's sealed to the sheetrock. Right. That's my first action item.
Well,
Yeah.
but how is that going to solve?
I want to hear your answer, because I was like what Chris was talking about, sealing that air up there around,
Yeah.
because that's what I'm familiar with. But what
And
is
sheetrock to the boot, baby.
So here's the thing. What do we, and this goes back to what Ty was talking about with the warmer air on the surface. How does that solve for setting the equipment up for the proper sensible heat ratio and having a low discharge air temperature, especially on single stage equipment, right? Because when we start lowering that coil temperature, we start lowering our airflow a little bit, we get a lower discharge air temperature. Well, that's going to cause more problems.
Yeah.
So
Like the job we were talking about last week. I got 50 degree air coming out of that register.
Right.
What was I saying? 50, 40, 49, maybe?
Yeah, it's cold, and that's going to cause the surfaces that air comes out and hits to be maybe a little bit above that. So maybe the surfaces are sitting at like 54, 55 degrees right next to that register. When unless you have the dew point of that house below 50 degrees, you're going to have all kinds of problems there, whether you have that boot
That is
sealed
true.
or not.
Yeah, your dew point would have to be below. I never really thought about it.
Here's an interesting one for you.
The
Ready?
numbers don't lie, you know?
So there was this very, very rich customer of mine who had one of those houses where they just have like this open floor plan that, it's like 2.5 stories when you walk in the door, go straight up, right?
Mhm.
He's got like 3 or 4 air conditioners in the house. Beautiful house, full of problems, right? Like I'll walk into the back of the house where you have like this half attic thing. And then I look between the first and second floor and I can just see straight through, right? And I'm like, wow, no even attempt to seal the heat. Like there's no continuous rim joist that's sealed, right? You see straight through, and I'm like, wow, right? And of course he's complaining that this room that's underneath that attic is super hot. And I'm like, well, yeah, I mean, it makes total sense. But let's get to the grills, right? The very top of the ceiling. And it wasn't bad. It was just like 3 grills that were just formulating a little bit of water on them. Hasn't even gotten to where it's like growing, bacterial growth yet.
Right. It's just,
It's just starting to bead water,
Right.
and I'm looking at it, and I remember calling Leaf, who's an engineer next to me. And this is the customer who's like, tons of money, doesn't care what it costs. And I'm just like, I evaluate the system. My supply air is coming out at say 56 degrees. You know what I'm saying? I've got a system. I take the grills down, the boots are sealed, and I'm like, what the heck? Right? Like I'm checking all the boxes.
Yep.
So I'm like,
that's normally what I check to make sure that thing is sealed to the dude. Sometimes I take the grill down and insulation comes in the face.
Well, so I do, I play all the boxes. Like,
so you checked all the regular,
I checked the
usual suspects, right?
And so I call Leaf and I'm like, Leaf, man, I don't know on this one. Like, I need some help. Like we're going to have to open up an investigation on this thing. So the attic to get to these ducts is definitely like this scuttle hole, no bigger than, tiny. You're just,
right.
I'm weaving through this thing. It's horrible to get to. And I get to up there, and in my area, we have a lot of these boxes that are like a 12x6 and they're internally insulated and there's a collar sticking out the top. The ones that are not in Manual D.
Yeah.
So like I go up there and there's water on the top of the box. And I go, that's interesting. And I'm like, is there a good seal? I'm looking into it, quality seal. And I'm like, well, crap. Where am I? Why do I have water on top of the box? So I call Leaf, and Leaf comes in. He puts some data loggers in that part of the attic, and we put one outside and inside. Now, this is before I knew how to really calculate this well and understand what I needed to do to investigate.
Right.
But what we ended up determining was the R value of the box, of the insulation in that box, was not thick enough to handle the battle of the runtime of the air conditioner blowing that air. And what happened was the metal on the top of the box was basically sweating. And then the water would formulate, and it would build enough water on the top of the box to where it would then spill over and then run to the grill. And that's what was. So, yeah. And so what did we do?
So you're saying run times? Long run times.
I'm saying if you've got it at,
you've
got R8 flex or R8 insulated duct going to a box, what's the R value of the insulation in the box?
Right.
Because it could be thinner and not R8, which is going to lead to potentially a box that's going to get too cold and condensate from the top side. And then that water is going to run down. So what we had to do to fix the problem is we went up there, we cleaned all the water off the top of the boxes. And then I asked Leaf, what do you want me to do? He goes, I want you to insulate all the way around that box. He goes, and it needs to be airtight. So here's another thing we need to talk about. You could insulate the box, but you also got to make a seal, right? Like that insulation has to be just like tubing insulation. Like if tubing insulation is great, it could be thick, but if there's a cut in it, that air can get in it, and that's going to cause it to sweat. Yep. So he's like, this was one of my best lessons learned by Leaf. He's like, I want you to wrap the box. He goes, then I want you to tape the ever loving hell out of it. He's like, I want no air to get into that insulated jacket. And I was like, why? He's like, because if air gets in, we didn't do anything. And I learned a huge lesson there.
That's a perfect place for spray foam, like what Jason, what's his name out of
Julian.
Jason Julian out of Arkansas does, where he spray foams the outside of all his metal ducts.
Julian Heat and Air.
Yeah, with he used close cell 2-pound spray foam, and man, because it's not going to let water through that insulation, so you know that it's good insulation. It's a vapor barrier, and it's air sealing everything. That is a perfect use case for.
And that's closed cell, correct?
Yeah, that's what termed as closed cell insulation.
And that idea actually came from outside of Earth. We had a visitor come in the 80s, and he was telling everybody in the movies, very own, foam home, foam home. And we're just not getting around to it.
Elliot,
Home, home.
Reezy Pieces.
Yeah.
I like
person,
movies.
that person just surfaced back in Mexico, but I think he passed away. Did y'all see the video?
Ty hit me with
No?
that earlier tonight, man.
That's right. The Mexican government came out and was like, yeah,
Yeah, we found ET.
we got these little ET mummies.
We
I don't
had
know if you
said
guys caught that.
he
Did
didn't,
you
ma-
guys
he didn't
catch
make
that?
it.
Yeah.
But for those bodies to have lasted that long, they had to have definitely had humidity control.
Oh, good point. Good
Yeah.
point.
Yep.
So how did they
They
handle
probably
that back
found
in the
those
day?
bodies in
Huh?
the Nazca line somewhere in the
kept
middle of
them-
the desert.
They kept them above dew point temperature.
All right,
Yeah.
next episode we talk about mummification and controlling dew point.
Yeah, mummification. Brought to you by embalming fluid. Tastes good too. Ty, I love those compressor videos you do, bro. That 2-speed Bristol that you're doing, I'm like, oh my god, we got Ty. Does anybody have that? He's like, nah, everything's decommissioned.
So
And then he finds one and's like, oh, let's take this apart.
I'm like Ty, send it to me. I want to make a Frankenstein compressor unit.
So I thought I knew a lot about compressors, and it wasn't until I was working with Don and I got to realize there's a whole another level of detail that go into that. So Don's the one that actually got me onto the compressor
Really?
side and all those little bitty things. And then Don introduced me to a bunch of other people that was like, hey, that has a name. Hey, this is called it. This is the reason for that existence. And then so now I'm like, well, I got to cut everything open because there's things that I don't know about. I got to apply that. So,
Thank you, Don.
Well, he's being humble.
Did you see
Yeah.
those videos were freaking cool, man? Dude,
Yeah, no, they're great.
the way that spring disc was coming off of that compressor head on that 2-speed, I was like, what?
I have
I'm like,
seen a lot
dude,
of
if we would have
compressor
pulled
videos
vacuums
lately
when
from
these
Ty.
things were like legit, when they were big in the wild, like if we pulled vacuums, flowed nitrogen, I'm thinking while I'm watching Ty's video, I'm like, shit, this damn thing would still be around. We wouldn't be stuck with all these LG freaking scroll compressors from Korea. Son of a gun. Right? We would have these nice Tecumseh like compressors. Dude, we're stuck with garbage now, man.
It's kind of like
I mean-
refrigerant. If we'd have done our jobs and kept the refrigerant in the system, we could probably still be using R12
Right?
or R22, you know?
Damn, we could have had some R22. Just carry that.
Did
Come
y'all
on,
hear?
get that gray and yellow tank, son. Come
Did
on.
y'all hear Bergman's statement that he made the other day about when his fireside chat was it there where he talked about how much refrigerant we could save if we would go non-invasive
Bro,
as
that
much
was
as we could?
crazy.
Yeah, I saw a figure on that here recently, and it was like millions of tons a year.
Yeah. It was
It was
like some significant amount. I'd like to talk to him to see how far he researched that and what
I don't think
was the
that came
variables?
from him. I think that came from someone else. That was, and I can't remember where I saw that at. I'm gonna have,
Yeah.
DOE study maybe.
but it was how much refrigerant we could keep out of the atmosphere if we did testing on refrigerant systems non-invasively, where we're not putting pressure gauges onto
Right.
a system every time.
Yeah, brought to you by like the appliance industry, bro.
Sorry, Doc.
my coils don't last 1 year. I'm putting gauges on every 7 months for a new coil. These damn units. These things are horrible. They're like
Well,
Swiss cheese.
That's part of the reason. I think I understand what you're saying. That's kind of the idea of the refillable or reusable tanks too, because of what that little bit of refrigerant that's in there by good practices to recover that out of there, right?
Yeah. I mean, you're
So-
losing a little bit every time.
But,
so
but the
a
thought
lot of
process,
people don't recover it.
and the thought process is if you do it and I do it and you do it and everybody around the world does it,
Yeah.
and you on the disposable type,
Yeah.
that's a lot of everybody putting those emissions in there. So that's kind of part of the reason for the recovery or the refillable or reusable tank, because if you take it back to them, it has a little bit in that heel. They know they're going to take it out.
Yeah.
That's the thought process.
Right.
That's why they're trying to do that. Plus tracking QR codes.
See, I don't understand what the push against the reusable, refillable cylinders is. Literally, all of our nitrogen cylinders are refillable, reusable. All our torch cylinders
Right.
are refillable, reusable.
Yeah.
How hard is it to do refrigerant?
Change. We don't like
Well, yeah.
change.
That's exactly what it is.
That's
It's
what,
change.
That's all I can
It's,
come up with
it's
too.
the same.
It's something different.
I mean, there
Yeah.
could be a few arguments made there. I'm just going to throw it out there, man. Like, how many times have you gotten a recovery cylinder from the supply house and then you use it the first time and then the threads are leaking and you're like, great, brand new, looks like a brand new tank, just got repainted, went back out, supposed to be leak free, and now it's leaking from the threads. That's happened to me countless times.
Mm.
Wow, really?
I think
Yeah.
that
That stinks.
I think it depends on where you're getting those cylinders from. There's a couple of recovery companies out there, reclamation companies that are doing a lot better job setting their tanks up
Yeah.
than some of the other ones.
But
Right,
getting,
and I'm sure they would pay
getting
way
back to
more
what Jim was
attention.
saying, I mean, I like it. I like what he said. He's scratching waffles. I like that whole scenario. Fireside chat. Love it, by the way. But, dude, the appliance industry, for some reason, seems more solid to me than the residential HVAC. So
I would ask a question. When a drum is done and it is disposed of, is the drum 100% basically recyclable and repurposed? I haven't followed that lead, but I'd be curious to know.
Disposable DACs, the DACs.
Like if you have, like current refrigerant in its
Mhm.
current bottle, are they I'm sure that's being recycled, right?
Well, it can be, but there's a lot of recycling places that won't take them because they may or may not have refrigerant in them, and they don't want to take the liability of that refrigerant.
yeah, they don't take the jug empty.
No, I
jugs
hear you.
anymore.
But here's where I'm going with
They'll
this.
take them.
Not all of them. There's
Really?
places that won't.
Because
Even,
I know on window units, at least years ago, the dumps would take. They would take them though.
Yeah.
and
Right, or
but they
BB
had to
gun.
be- the refrigerant had
Yeah.
to be out of them.
Yeah.
So here's a
there's
business model
places
for
now
you.
that aren't taking them because they're a refrigerant drum. Like you have to completely smash
Wow.
them in order
Okay.
for them to take.
Yeah,
Yeah.
we used to have to cut them in half.
Yeah.
So someone would take them.
Cut them in
Yep.
half.
Yeah.
Oh,
So-
come on now. That's a little ridiculous.
But that being said, imagine if you started a company that said, "Hey, don't bleed the drum dry. Just send it to me."
But here,
Right.
Right.
here's
You
the-
could keep all of that leftover refrigerant. That just
The company's called Give Me Your Vapors.
Give me
you
your.
look
Yeah.
at all of our. Look at all
And then Ty's gonna suck all the refrigerant out of all the oil out of the compressors. I love
Look at
that
all
video,
that.
bro. I love that video.
look at all in the supermarket industry, they get the 100-pound cylinders or 110, 125-pound cylinders. All of those are reusable, refillable, returnable cylinders.
Mhm.
We already
Are they
know-
really?
Yeah. Those aren't disposable. Those are
So
reusable.
Eric's not trying to change the industry. He just wants to do what's already been done.
Canada's already doing it.
Do we have to lobby for this, or we
Canada-
got to call
Canada's been
FRACA,
doing
ACA?
Well, they're
Schmack-
all lobbying
Schmackna?
against
Against
it right
it.
now.
ACA, Hardy,
They're
Two other
lobbying
organizations.
against it.
Yeah.
Um,
and they want
Vapor Wranglers, baby.
they-
Woo!
it just
but
needs to be rewarded.
Europe's been doing it for a long time. Canada's been doing it for a long time. And we return basically every other cylinder that's on our truck already that we get gas in. I couldn't figure out what the problem everybody had. with
Yeah.
those.
Either.
I don't know. Jim's on to some next level shit all the time. Because
I
I
think
mean,
it-
the invasive measure quick, I do like it,
You mean
and I got to
you mean
start doing it
non-invasive or
myself,
invasive?
man.
I
Invasive,
don't think
The non-invasive.
non-invasive. Okay.
I'm a little invasive
And-
myself.
and
So.
okay, so for the record here, everybody, what non-invasive testing does, non-invasive testing looks at the heat movement through a system without getting pressure readings on the
Right.
refrigerant.
I feel like Eric is my HVAC verbal lawyer.
Well, I just
I
wanted
love
to
it.
clarify that in case anybody has a question, because a lot of people hear non-invasive and they're like, what does that mean?
It's true. We always talk like we think the audience knows what we're saying. We kind of got that,
Yeah, we're
But
guilty
you're
of
right.
that.
So
I'm guilty of it, man.
when we think about a refrigerant system, there's 3 times that a refrigerant system should be opened up during its life, right? When it's new and commissioned, if there's a problem,
Yep.
right? And at decommissioning.
Yep.
But otherwise, all we're doing is moving heat from point A to point B.
I agree with Bergman.
Why do we, and how, Don, how many times have you had a technician out to put gauges on your refrigerator?
Exactly. No, we say it all the time.
I mean, dude, you make that statement and it's done. It's like
No.
nobody should say,
Bring
Shit.
him back in the house.
Yeah.
I'm letting house.
yeah.
I think
Yeah.
Bring him in here.
How many times your appliance guy goes, oh, let me just throw the gauges on that refrigerator.
Yeah.
Never.
I like non-invasive, and I get what you're saying, 1, 2, and 3. But I think there's potentially a lot more 2s that are going to happen than one time. You know what I'm saying?
I will agree with you if the first time was not done correctly.
Okay.
Hmm.
If the first time is done correctly and that system is properly commissioned the first time,
Yeah.
not just turned on and setting the superheat, that is not commissioning. Because the
Yep.
first thing before you can do that, you got to set the airflow,
I agree. I
right? And
agree.
you got to measure that airflow.
Get your true flow grid on there.
Throwing house
You
out there
gotta-
again.
You gotta get it commissioned. I mean, Brian Orr was talking about this years ago, man.
When I was in the field,
Train has finally come out with a commissioned unit with the TAM 10.
I learned about this
It gets commissioned.
non-invasive thing back in late 2000s. We'll say 2007-ish, I think. It was around the time I started using digital gauges. And I switched to a non-invasive testing methodology this was before pre-measure quick, pre-eye manifold, pre all this stuff. It was really actually just some pretty simple math. And I could nail things every time. I did it I think I did about 24 systems, checking myself against my gauges and without my gauges. I got to where I stopped putting gauges on systems,
Wow.
right? Especially when I was doing maintenance.
So we got a
Because
question.
I could find more problems. Because
Got Steve in the chat. I love it, man.
I started looking at the movement of heat rather than the movement of refrigerant.
Yeah.
Well,
That's my experience.
The first version of
non-invasive.
non-invasive, I did not like. The Bear Can Cold was the first. I did not like that version at all.
No,
Right?
not even a good dark beer.
No, none.
Usually, if you take your boot off and you put your toes on the suction line, you get a good beer can cold on there.
That's toe can cold.
He's token.
It
Steven,
was funny. Like last year,
Yeah.
I got a picture of that. It was so
a
funny.
non-invasive tests usually tell you if there's a reason to gauge up.
I mean, dude,
Absolutely. Yes.
would-
A good non-invasive test, if you know what you're looking at, will absolutely tell you if there's a reason to gauge up, but you
Yeah.
have to know what you're looking at and you have to really understand that system. And you've got to know, okay, I'm not just going to put liquid in suction line. I'm going to take liquid suction line. I'm going to look at my enthalpy difference across the indoor coil.
Okay. I'm going to go with action item here.
I'm going to start looking at my discharge line temperature on that compressor because
Mhm.
Don and Ty, what can discharge temperature on a compressor tell you about how well that system is running?
Ty's he's been talking about this lately like crazy.
a lot.
I posited a question years ago actually I asked in a couple places. One of them was in the HVAC school group. If you had to walk up to a refrigeration system and take one reading, you were only allowed one single reading on that system, what would you choose? And I'm going to ask these two guys sitting here.
Ooh, that's a good one.
Well,
Action item.
only because of the years at Copeland, but I learned so much about the importance of. I always tell everybody to add that to your tool belt. If it's not on the invoice, if you can get to the discharge line and you can take a reading there, because
Wow.
I always compare it to, you can't see inside a compressor, right? They're not made of plexiglass. But if you take a
Right.
temperature leaving the discharge line 6 inches out, and you have the temperature of like return gas going into the compressor, or even your superheat, you've just told yourself a lot about that system. I mean, that's huge, right?
Dude, you guys are getting me mad. Now I'm gonna have to go to True Tech Tools, get another temp clamp. Oh man.
But
I'm gonna be pulling the fan off on every job.
To
Throwing
me-
that discharge. I'm gonna get that discharge temp. I'm gonna do it.
I,
Because Brian Orr's been alluding to it for years.
I want to know what's up with that discharge temperature on every job that I do, because that tells me once I learned
It's
about
that big.
oh,
Damn.
it's huge.
Yeah.
Yeah, because if you got the right compression, then you're somewhat close on the suction. Yeah, man.
But if you have the right amount of refrigerant flowing
Right.
through the compressor,
Right.
it's going to be a reasonable discharge
Yeah,
line
I
temperature.
think one of the first things, and I know a lot of people think this way. I'm sure I know Ty does, but one of the last things one of the things I say in class a lot of times through the years is the last thing you want to do is gauge up. You know, you can do a lot with the temperature probe and those kind of things. I mean, you know, that's my personal take on it.
That's cool, man.
Ty's got something to say over there. He's been itching.
Oh, I got tons of things to say, but with all the technology that we
Spit it,
have,
spit it, Ty.
I mean, our equipment should already be checking superheat, subcooling, discharge temperature. Anyways, we have thermistors now that are mass produced at an affordable price. We have the technology. The control boards are already on like everything. Anyways, you know, the fact that we still need our gauges, you know, should only be if the equipment's saying that there's an error and we want to confirm if it's a bad sensor or there's a problem in the system. To me, like the analog gauges, and I know I upset a lot of people with this. I'm not trying to hurt anybody's feelings, but really that set of gauges that everybody loves so much, it's an antique. I mean, it really is. The hoses are so much loss in it, contaminations. When you have the hose, even if you bleed your ports out, you're getting contamination back in that system, even if you pull it back in the first time. So yeah, I love the wireless probes. That really, even that's outdated. The equipment should come with it. Like the vehicle we drove here has a check engine light that tells us exactly what the problem is with the system. As technology is moving forward, the equipment should be monitoring at discharge line temperature, monitoring suction superheat, monitoring our subcooling. It should be monitoring this already anyways. And then we can Bluetooth into it, plug it to it. I don't know how they want to connect to it. It's a separate issue, but the equipment has the capabilities and it's affordable now. They can already be doing that.
That's right.
The second thing is, I don't really care about the tanks, whether it's recyclable or not. Why are we still putting new houses? We're putting equipment in unconditioned attics like that. That to me, it boggles my mind. And then the third thing is, why are we so concerned with energy mandates and using less electricity, making the equipment more efficient when we ignore the house altogether? Leaky
Come
house
on, Ty.
for construction.
Spit it. Come on.
The efficiency of the equipment doesn't even matter at that point when, you know, hey, we're going to have this engine that gets 50 miles per hour, but we're going to put it in a Freightliner. And it's like, okay, we'll put that Volkswagen engine in that Freightliner. It's not going to do anything. You know, we have to look at the whole thing.
But Ty, we've been doing this, for like 100 years like this. Why should we change now?
It's because we're the subcontractor.
Yeah.
And we don't get to make the call. And it's a big letdown. And
So
so
like we're at a Trump like a Ty rally. Go Ty.
I'm just going to say this. We need more consumer homeowner forward facing content. We keep saying it, but we got to do it. We got to bring it straight to,
I want to hear people say, get that air handler out of my damn attic. Let's go.
Yeah.
Or
Right on.
condition the attic. That have to be out completely. Just control it
Condition the attic.
properly, not just one solution. That's
All right, guys. So here we go. Round table. We're out of time. Let's have one takeaway action item. Are we ready to do it?
From each of us?
Yeah, why not? Michael, you go first. Putting you on the spot.
What are we doing now?
We're doing action items because
Action
I
items.
love action items.
Chris needs something to do tomorrow, so you're giving him something to do.
I think we gotta focus more, like what you're saying. We gotta focus more on consumer content. We gotta have more questions coming from people out, that are homeowners. They need to know about this because a lot of AC guys, I don't know, man. I feel a little pushback. I don't know about you guys. There's a little pushback. They want to just do whatever they can to get by, and there is some diamonds in the rough, and they're usually in the group. They're watching. They're in some form of group. They're in Brian Orr's group. They're in the overtime group. They're in our group. But I feel like, and I hope I'm wrong, the percentage is not, it's low compared to what's out there. So I feel like we need to focus more on homeowners. So I'll leave it at that.
So, all right. Batter up, Eric.
Batter up, me.
Batter up. Yep. What's your action item?
I think we got to focus more on discharge line temperatures of compressors.
I like that. I like that.
Start measuring that discharge line temp. You'll learn a lot.
Yeah.
Watch some
Okay.
of Don and Ty's videos. They'll probably tell
What's
you what
All right.
what's the discount code for True Tech Tools, Chris?
We don't have one. They don't. They didn't execute us one. We're not famous
Are you
enough, bro.
kidding me?
Is it Ty Banana Man?
Is this being recorded?
All right, I'll go next. Here's what I'd like to see. I would like to see new homes being built come with data log monitors in the home. Right?
Damn.
I want to see one in the attic. I want to see a thermostat that can also give me reported data, which is common, but that's not always what we put on the wall. I mean, these, like, not to name drop, but like the Govee sensors aren't that expensive, right?
Yeah.
We could create some type of product where you're going to say, hey, I got so many sensors, every house gets one, build it in the price of the house, right? Because a house is hundreds of thousands of dollars. Why can't we just have a couple sensors that report data of how the house is acting? Then we could
Right.
play the house as a system game on data we've collected versus all the work we have to do on site immediately to try to derive to that same data, right? We could learn a lot from seeing the trended data of temperature, relative humidity, and dew point and all these various conditions. I also would like to see if we could just get a manometer from inside to outside.
Oh, God.
And data log that
Now,
with
now you're pushing it. Now you're pushing.
That'd be super
TEC
cool.
just bought out Hobo instrument sensors. Just wanted to let you guys know.
I'm just saying that would be my wish. That would be my action item. If we're going all the way, that's what I call all the
Data
way.
loggers. I mean, I like it, dude. That's
want the whole
cool.
house
I mean,
data
hold
log.
on, man. Let me check. Let me check the data logger in the attic. You know, I mean, that's a lot of information.
Yeah.
That would be
Mike,
crazy.
Just to follow up, Michael's house says report it to whom? I just want it to be saved. It can be saved to the thermostat wherever, to where it could be reached by anyone who wants to look at that data and make a quality decision.
Yeah,
So it doesn't necessarily have to go to anybody. It could be part of the system.
that's
And
cool.
it could just say, for 1 year, and then after 1 year it drops the day. Boom, boom, boom.
It erases it like a dash cam. I
Right.
love it.
Yeah.
Let's
you
do
get 1
it.
year's worth of data.
I
All
like
right. So that's my takeaway. That's my action item.
Don, how about you?
Don.
Mine is going to be something like what Ty said earlier, because it's been an argument in the beginning of my career when I roughed in houses and was out there pounding tin knocking and stuff. And it's kind of something off what Ty said and a little bit of what Chris just talked about is I think the builder, the contractor on new homes should give more leeway to the HVAC contractors. They should build the home with with more respect of what the HVAC installer does, the contractor does. I know in some areas around Indiana and Ohio, they don't even cut you areas to where you can even run your chase up on a second story house. You know what I mean?
Right.
You have to figure out how you're going to do that. And that used to bother me a lot. And a couple
It's
builders,
unbelievable.
yeah, I trained them actually when they had basements. It was like, it's real simple. Just cut me like a laundry chute right here. Just give me a spot. Just give me something. I know square footage is expensive and the homeowner doesn't want that, but it has to be that way or I'm going to be the one coming back for these comfort calls all the time. You know what I mean?
Uncomfortable homeowners aren't expensive, though, are they?
Yes, they are.
Yeah, right.
You know,
More or
yeah.
less than a couple square
Yeah.
foot of real estate in your house, right?
Exactly. And I don't think at least from my experience, I don't see builders giving enough respect to the mechanical because when it's all said and done, if it's pretty and it's not comfortable, then it's just a lot of wasted time, at least my experience. I dropped a lot of X13 motors in years ago when they were on slabs just because the ductwork was so screwed up. It was the only thing I could do. It really wasn't fixing bad ductwork. It was putting a Band-Aid on it. But you know what I mean?
Oh, right.
I'll digress. I'll shut up.
You mean if they were a PSC motor, you're doing X13?
Yeah, you had to.
Oh, okay.
Yeah,
How
to
many
do something,
builders would build slabs in this area that I'm in right now I don't know
Gotcha.
about here in Indianapolis, but they would build 2-story slabs. The ductwork would be in the concrete. Then they'd run, wall stack in the walls, and you had, and young homeowners would sign these contracts and not realize they think they're getting air conditioning, and they're naive, but the builder's thinking, that's what they paid for. You know what I mean? And I'd be
Right.
in the middle of it, like, no, they don't know that there's going to be a 15-degree split from the upstairs to the downstairs. And I don't like to, I don't
man.
tell them that, you know what I mean? So, I would give $400 motors away, just
That's
because
rough.
it's the right thing to do,
On a new house too.
And you think you
Yes,
got it rough,
all the
Mike.
time, all the time.
Oh, yeah, I thought we had it rough down
It's
here.
the same thing with a
Jeez.
slab. If you have a 1,500 square foot footage of a slab, builders will say, "Oh, this one's worth this one, this one's worth that." But a homeowner, a young couple, doesn't know that. In
Yeah.
our area, if you don't put that ductwork in the slab and keep that concrete conditioned in the wintertime,
Yeah.
it'll pay dividends compared to having it in the attic up here. Because that, you know what I'm saying? It's just like kind of going back to what Eric said earlier about the radiant heat and the tubing. There's a big difference in comfort there, So, anyways,
It is.
My action item would be to every house have a digital display above the door, and it has the CO2, it has the humidity, it has the particulates, and how many watts of electricity they used the previous month. So that way,
Ooh.
it's going to look cool if they have all these things under control. And if those things are
Wow.
out of control, then maybe you don't want to go in the house, or it's like, hey, I don't want to look uncool to my neighbors or people coming over. So
Yeah.
make the
I
air
like that.
cool.
And then have it chirp like a bad smoke alarm where the battery is bad.
Is
And then, and then we can include Chris's idea with the data log and throw it right in there, bro.
and
We're gonna squish your stuff together.
over the front door of the house, we're gonna put this thing that looks like a stoplight, green, yellow, and red.
Yeah. Don't come in here.
Ty, I'm gonna tell you, I have a lot of clients who would totally dig that because they like to compare themselves. I did a lot of work for people who kept up with the Joneses, you know what I'm saying? And that would be a competition to them. And
Yeah.
boy, would they eat that up. I mean,
Yeah.
I've watched these people spend big money. Like
Yeah.
one neighbor gets a garage door full of glass, and the other neighbor's like, "Oh, we got to have that. He got
Yeah.
it. I got to have it." If we
Have
could
you
get a
seen-
competition going on like wattage, that'd be pretty cool.
You see my low level CO2s? You see these? Yeah. That's like,
Because
Bro.
is spending $25,000 on a solution and nobody can see it?
Yeah,
yeah.
I
It's
like
true.
that.
good point.
He's got
That's a
point.
very
You
good
got a
point.
That's
good
why a
point.
lot of rich people they didn't want to buy the high end AC because their neighbors couldn't see it.
Mhm.
Well,
So-
when I had my business, even if it's the cheapest equipment, we put in the nicest looking thermostat and an easy to change filter. Because those are the only two things the customer sees: the thermostat and the filter.
Right. Yeah,
That's true,
I like
man.
that idea. Can we not
Absolutely
put
right.
this on YouTube and just let's like invent that idea? So nobody steals it. That's
Nobody
patent pending,
watch.
right?
Nobody watch.
Yeah.
Kill your
Right now.
computers right now.
Yeah, I think we could. I think we got like 30 viewers. It's all right.
Well, Ty and Dom, I appreciate you guys coming on tonight, shed some light, making us just that much more famous.
Yeah, man. Thanks, Eric, for setting this up, man. That's freaking
Yeah.
cool.
Hey, when you got friends like this, that stop by for dinner, and I'm like, hey, man, it's on the same day. And this was yesterday that this hit me in the head. I'm like, holy cow, I could have them on the show. And here we
That's
are.
awesome, dude. That is
Yeah.
so cool.
Yeah,
So
He put 3 mics out. I was like, what is going
Yeah, man.
on, man?
super
No.
fancy.
I know. Well,
Appreciate you guys coming on, man. This was cool. This was really
Yep.
cool. Like I said, if Chris didn't invite me to the show, I'd be watching. I'd be in the comments.
All right, that's it for the night, guys. See y'all later.
thanks, everybody.
Later.